Welcome everyone to the Intel Network Builders webinar program. Thank you for taking the time to join us today for a presentation titled How ASUS, Intel, and Silicom Position Edge Products into 5G Architecture. Before we get started, I want to point out some of the features of the BrightTalk tool that may improve your experience. There's a questions tab below your viewer. I encourage our live audience to please ask questions at any time. Our presenters will hold answering them until the end of the presentation. Below your viewing screen, you'll also find an attachments tab with additional documentation and reference materials. Finally, at the end of the presentation, please take the time to provide feedback using the rating tab. We value your thoughts and we'll use the information to improve our future webinars. Intel Network Builders webinar series takes place live twice a month, so check the channel to see what's upcoming and access our growing library of recorded content. In addition to the resources you see here, we also offer a comprehensive NFE and SDN training program through Intel Network Builders University. You can find a link to this program in the Attachments tab, as well as a link to the Intel Network Builders newsletter. Today, we're pleased to welcome Albert Wu from ASUS and Oren Benesty from Silicom. Albert Wu is the current division director of the ASUS Server and Workstation Business Unit. Albert joined ASUS in the year 2000 and has built an extensive and invaluable experience of developing server products for the telecoms industry, from the initial design stage to the production of world-leading complete solutions. Oren Benesty is Executive Vice President for Strategic Sales at Silicom. Oren has a bachelor's degree in electrical engineering and a master's degree in business administration. Oren has over 20 years experience in the telecom and data network infrastructure design. Welcome, Albert and Oren, and thank you for taking the time to join us today. Albert, over to you.
Okay, thanks for the Lilian and Intel's arrangement on that. Hi, this is Albert from ASUS Tech. I think it is my great honor to join the webinar. Today, I would like to show you about what we are planning for the three-way collaboration and the solution on the 5G edge. At first, talking about the 5G opportunities, from the infra point of view, no matter what kind of the definition from the cloud, network edge, or on-premise edge, most important is how to leverage the 5G features as the low power, low latency, and the fast speed with more connection. Then, apply the such solution on the vertical like industry, medical, and the traffic to enhance the convenience for live implement. However, due to the 5G edge, which owns the key features like open and flexible for development, and it covers a so widely field like hardware design, networking, and system architecture. So that's why we initiated the three-way collaboration for the 5G edge between the ASUS, Intel, and the Silicom. We plan to have the optimized edge solutions which integrate the Intel the flash RAN and the Silicon core technology on networking. Then ASUS would consolidate all the technology into the best fit for the 5G edge application. This cooperation delivers better solution with strict testings and optimization in hardware and firmware design. Later on, I will show you in detail. Here, let's talk more about the joint design concept. As mentioned, all the design is based on the Intel flash RAN architecture. Surely, we adopt the Intel network optimized processors and networking adapters. Then leverage the Silicon two major core technology you can see from the screen. The first one is the time-sync technology to ensure the accuracy and the synchronization while data transfer. And the second one is FEC technology which enhance the quality and the efficiency within transfer. Besides that, ASUS focused on the design of the DU and the CU servers to consolidate all the technology into available and flexible solutions, which contain the key features like short chassis from ASUS and the NAPS compliance. Along with ASUS hardware design experience and all the code technology, ASUS Edge server deliver the optimized design to the telecom market. Okay, here, as we previous introduction, our design is based on Intel Flash RAM. This innovative architecture provides the possibility on Intel-based server to penetrate the telecom market, allow us easy to integrate on top of the software architecture and the superior Intel processor performance. On the other hand, ASUS will also engage closely on the Intel Select Solution certification. This can also shorten gaps while implementing the Flash RAM product to the telecom market. About Silicom, I think that they deeply focus on networking applications like time sync, forward error correction, and the smart NIC technology. These ingredients are the pivotal to the 5G application in the monitoring, management, and the enablement. So, ASUS feels so great to have a partner like Silicom. We try to have the testing and validate on each other products. No matter on ASUS general purpose servers or the proprietary ones, Silicom product work very well on it. Our partnership is so great to trigger adoption in the 5G segments. Here, let me introduce you about ASUS core competency. ASUS servers is not just rooted on the hardware design, but also pursue the greater performance and economic power consumption. Through the dedicated team efforts to create exclusive tuning technology and innovation. That's why ASUS server can get over the 850 for the worldwide #1 benchmarking the records in spec CPU. Meanwhile, ASUS didn't compromise in power consumption for the green purpose. All these technologies are easy to access through the BIOS or the BNC. As mentioned, the ASUS product portfolio can meet the different use cases, from the cloud to edge. You can see here on the right side, there's high-density server for high-performance computing. Also, we have the AI GPU servers to expand the application in the AI training and the inferencing. Along with the coming the 5G era, ASUS also develop edge servers like one usual desk and compliant multi-nodes as well. More complete portfolio would be the coming soon in the near future. Let's have some overview on the ASUS server and the edge solution in the following pages. Here you can see the ASUS servers always features on the latest technology and implement into the hardware and the firmware design. We would like to keep all the product have the focused strategy on the flexibility, scalability, and the versatility. Among all of that, you can see here is the balanced design. This architecture is one of the key features, which allow the end user every penny counts. That means ASUS fully utilize layout to maximize the scenario coverage and give the best advantage to customers to their applications. On the other hand, we also support to release our essential technology through the BNC. Then you could get fit setting on your preference. Last but not least, you could get a hardware root of trust option in our third generation Intel Xeon platform too. Then, within edge server design, ASUS also offers the one use case you can see from the right side here. And multi-node edge as well is the left side. We call the EG3050. To comply the critical challenges in ambient temperature and location, which owns unified features like from access for the convenient maintenance and the DCSE in to meet the different location requirements. Most important of all, passing NAVs to ensure the edge servers satisfy the regulation in the telco industry. Here you can see what we provide are not just on the hardware feature. It's also important on the high availability of the firmware for your application. So we dedicated to address you all the available firmware in 3 ways. The first one, easy to maintain. ASUS 5G server design complete the fail-safe mechanism in the firmware including BIOS and BNC. The dual images to low impact in sudden shutdown and reduce overall TCO. The second one, easy to safeguard. We also deploy the hardware root of trust to block malicious firmware attacks. Security are the top priority to ASUS server, as always. And the third one, easy to deploy. The ASUS co-work with the independent software provider to ensure the full compatibility between the hardware and the software. In fact, ASUS, all the servers have to pass tests and certification from the key platform provider, like Red Hat Linux real-time, also with the Wind River Cloud platform. These platforms are standardized to meet the telco use case and very free to launch new service. Okay, that's my section. Then I will hand over to Silicon Oren. Oren, you go.
Slide number 12. Great to have you all over here today. So when we're looking at the 5G market, it's great for Silicom to collaborate with ASUS. ASUS provide the servers, as you can see in those pictures, we can see the server already equipped with a dedicated add-in cards as accelerators. You can see the broad range of add-in cards from standard EASIC cards based on Intel ACC 100. We have FPGA cards for accelerator of layer 1, and we have a time sync. In the next slide, we'll get into more details regarding all these cards. On top of that, Silicom also offer an IPsec card for encryption. We've seen a couple of operators looking to encrypt all the traffic from the DU to the CU and from the CU to the cloud. The last card that we'll present today is UPF accelerator for the 5G core that can accelerate up to 400 gig of traffic. When we're looking at the 5G market, we are seeing all the network connected using standard off-the-shelf servers we're seeing standard add-in card, PCI Express, and all of these serve the market with a time sync connectivity. So we're seeing the GNSS receiver on top, the GPS satellite provide the clock into the DU. The DU can provide this clock into the 5G radios. On the left-hand side, we see the radio units. Those can be connected with the CPRI based on the ORAN standard. And today we are in development of FPGA card for the open front hall. Moving to the next slide, we'll get into more details into the card. First of all, you can see a fully server equipped with a time sync card on the right-hand side with 1 PPS in, 1 PPS out, 10 megahertz in, 10 megahertz out, and we have time of day. So the first card that we'll discuss is STS. STS is Silicom Time Sync. Silicom Time Sync provide connectivity based on Intel EA10. EA10 is Intel Ethernet controller, codename Columbiaville. It supports both 1588 and SyncE. The line of STS cards include a range of cards with 4, 8, and 12 ports. We have a GNSS receiver on most of our cards. So for cost reduction, we have some cards without GNSS, but most of our cards include the GNSS receiver. It means that we can be grandmaster. We support both boundary and transparent mode. So we can function to recover clock both from the front hall or the back hall. We have holdover of 4 to 8 hours. And in a specific temperature, we are able also to do 12 hours and even 16 hours. Again, depends on the OCXO that we have on the board. The BMCA is a very interesting feature. BMCA is best master clock algorithm. When we are discussing clocking, we can get clock either from the backhaul, it means from the transport network. Some of the radio heads also include the GNSS receiver, so we can recover clock from the front hall. We can have a GNSS receiver on the card itself. And all of these create a range of clock sources. Silicom implement best master clock algorithm in order for the card, or specifically the DU, to provide the best clock in the system. So this means that we are able to recover the clock from any source based on its quality. Of course, when everything fails, we are moving to the OCXO and we are doing holdover. The second card, called Pomona Lake, in Silicom codename, it's called Lisbon, if you look in our website. And this one is based on Intel ACC100. ACC100 is an eASIC. It's doing both LDPC and turbo, LDPC for 5G and turbo for 4G. It's integrated into the server using the BBDev driver that integrate into the, sorry for moving to the next slide. It supports the BBDev for the integration to the FlexRun. We have few versions of these cards, standard temperature, 0 to 45, and extended temperature that range from -5 to 55. And of course, we have a BMC on the card to manage all the thermals on the card itself. This card is working in a look-aside model, and I will elaborate in a second. The last card that we're seeing on the left-hand side is an FPGA card. The FPGA card, we have two versions, one based on ARIA 10, and the second version based on Agilex. This FPGA card can perform a layer 1 acceleration. It means that it can do LDPC, very similar to the Pomona Lake. It can do a front hall connectivity with 8 ports of 10 or 25, or 2x100. We support, of course, time sync. It means 1588 and SyncE. We have holdover, very similar to the Silicom time sync card. GNSS receiver, so we can be grandmaster. And we support the native clocking mechanism, boundary, and transparent modes. Of course, we have the code for the best master clock algorithm, so we can select the best clock on the FPGA card. And we're compliant to the ORAN C1, C2, and C3. When we're looking at all these cards, we have to remember one thing. In the 5G market, we have a different deployment models. Some companies deploy it as a software only. So they will use the STS card just for connectivity and time sync to the radio heads. Some companies are looking to do acceleration to the FEC. It means that they will use the ACC 100 for offloading forward error correction. And this will be in a look-aside model. It means that the traffic coming to the system through the STS card, moving to the ACC 100, back to the host system, and then moving out to the CU. The last card, the FPGA, can perform functionalities way beyond FEC. So it can do, first of all, the functionalities of the STS. It means connectivity to the radio head, including time sync. It can do forward error correction. And in the future, it will be able to do more functionalities as part of the layer 1. So this is a range of platform, range of cards. We are able to accommodate any deployment model that the software vendor will decide. And more of that, we are able to provide software vendors the ability to differentiate, whether it's a software, whether it's a partial offload, or it's almost a full load offload of the layer 1 acceleration. So this is very interesting range of product. All of these are integrated into the ASUS platforms, and we're able to provide a product for POCs. You can see the example right here in the middle. Moving to the next slide, I'm always getting questions about the time sync capabilities. First of all, Silicom is fully compliant to the ORAN requirements. We are following both ORAN, TIP, and ITU-T. We're implementing on the time sync cards, both the STS and the FPGA card, 1588 PTP, both for IP version 4 and version 6. We support Sync-E based on ITU-T 8262. You should ask yourself why we are doing both Sync-E and PTP. And it means that we are able to do synchronization based on time, frequency, and phase. The system is synchronized based on PTP, and we're using Sync-E to improve our accuracy. The card, as I said, supports both boundary and transparent based on the 8273.2. And of course, we are supporting Grandmaster based on 8273.1. We are supporting both PRTC and ePRTC. So we can be class B for PRTC. And we have an OCXO Stratum 3E. 3E is the enhanced one. It means that we are able to hold over the clock, as I said before, in normal temperatures. We are able to do 16 hours, but we are committing for 12 hours. And at extreme temperatures, we are going down to 4 to 8 hours. So everything is dependent on the working temperature of the DO. Of course, everything is coming with software drivers for the x86. We support Red Hat, VMware, and of course, WindRigger. All those will have in their next release our drivers, and there will be seamless integration into the software layers. Moving to the next slide, I will get now to the next level of details. The first card that I would like to discuss called STS1. STS1 stands for Silicom Time Sync number 1. This card is the entry-level card. It supports 4 ports of 10 or 25 gig. It's equipped with Intel EA10, which is Colombiaville. Temperature range between 0 to 45. And this card is half height, half length. Over here in the picture, you can see it's a full height because we are putting the 1 PPS in and 10 megahertz in as part of the bracket, but we have also a smaller bracket for installing in different locations. This one supports PTP and SyncE, of course, transparent and boundary clock, and we have grandmaster capability. The grandmaster capability is done using an external GNSS receiver. We are not equipped to have a GNSS receiver on the card itself because of its size. This card also implementing the best master clock algorithm, so we can have either clock from transparent on boundary, means from frontal or backhaul, as well as the 1 PPS and 10 megahertz. Moving to the next card, it's called STS2. STS2 is 8 ports by 10 gig. This card having all the feature of STS1 with double the amount of ports. It means that if in the STS1 we had 4 ports, over here we have 8 ports of 10 gig. This one also have PTP and SyncE. And on top of that, we got the GNSS receiver on board. It means that we just need to connect to a GNSS antenna, and by that we have a grandmaster capability within the card. Of course, we have 1 PPS in, 1 PPS out, 10 megahertz in, 10 megahertz out. So we can either cascade the system, we can provide external clock to the card, and we're able to do also the boundary and transparent. So it means that we have all the clocking features available. This card have the 8 ports, so you can see in the picture it's 4 ports of 10 gig discrete ports, and we have 1 port of QSFP that with another 4 ports. We have done this one mainly because of physical limitation of the panel. Moving to the next one is the EASIC. Just last comment about the STS card, so I'll move back to the previous slide. We have STS3 coming in the future. It will have 8 ports of 25 gig, very similar features, and we have STS4 with 12 ports. The 12 ports have a very unique capability because it's enabled us to remove the switch between the DU and the radio units. So together with ASUS, we are able to build a server that have 12 ports connectivity, front-haul offloading, and by that we can provide a system that does not require any external devices, like switches, for example, like external clock sources, and we can provide a system fully ready for a POC. Moving to the next card, it's the EASIC. EASIC code name at Intel called Pomona Lake. This card is based on the EASIC technology. It means that Intel put all the technology for LDPC and turbo within an ASIC, and by that we can create an offload engine into the LD and the forward error correction. The mount brace itself is fully integrated into FlexRAM. The first version that supported the mount brace, which is the chip of the EASIC, was version 20.08, as you can see in the slide. Since then, there were 20.11 and many newer versions, but this is the first one. So if a software vendor looking to implement this one, make sure that you have the right FlexRAM software. Those can be downloaded from the Intel website. If you cannot find it, please send me an email and I will provide you a link to the Intel site so you can download the right software. The card is PCI Express Gen 3 by 16. Of course, half height, half length. We have brackets for full height and half height. We implement a BMC for monitoring and control, so we are able to control the thermals on the card itself using the host system BMC. We have a version for OCP as well. And the temperature range for the industrial version is -20 to 55. It means that some of the outdoor system can use this card as well. It's optimized for 40 watts, so no requirement for external power source. Moving to the next slide is the FPGA card. As you can see, the FPGA card is a bit more complex card. In this card, it's very similar to the Intel N3000. N3000 for Intel included two Fordville MAC and ARIA 10. And what Silicom added to this card, we added the time sync. So we're able to convert all the code that was running on the N3000 and also to provide the time sync capability. This card is based on the ARIA 10 from Intel. The next generation that we launch in few months will include an Agilex. Agilex is the next generation FPGA from Intel, and Intel already announced such a card that it will be in the future as part of its technology day. This card today is based on PCIe Gen 3 by 16, support, of course, 1588 and SyncE, and we have a GNSS receiver on the board so we can be grandmaster as well. Because this card is optimized for power in a range of about 75 watts, so we don't need external power source to the card itself. So all in all, what we can see that we provide a range of cards that can support any deployment model. It can support also capability to create both connectivity and acceleration for the layer 1. Thank you very much for listening, and now we'll start answering questions.
Fabulous. Thank you, Oren and Albert, for this great presentation. We do have several questions that have come in while you were presenting, so let's get started on the Q&A. First question I have here, does ASUS have any POC in telco segment?
Okay, thanks, Dylan. This is Albert, sorry. Recently, I think the ASUS engaged with the Taiwan telco service provider to have the POC on the 5G private network, so that we would have the more use cases and emphasize within it. And we would hope to work with the top vendor to create a real business case in the 5G application in the near future. Thanks for that.
Thank you. Thank you, Albert. Awesome. Second question, I have another question for you, Albert. What are ASUS hardware design concepts for ORAN servers?
Okay, thanks. And I have our senior leader, Cherry, here for the hardware architecture planning. So the Cherry, would you help to answer this question?
Of course. Hello, everyone. This is Cherry speaking. ASUS core competency is that we design our own servers. We have proven performance tuning capability, excellent thermal and grid computing design experience. Hence, we always optimize our products for different workloads. For DU or CU servers, we want to design products which can fit for the base station environments. So the design question will be how to let servers run smoothly and with high reliability and availability in a tiny space. So we design our server with short dash chassis and front access design, so user can maintain at front side very easy. Also redundant power supply with support to both DC in and AC in. Our server can be operating in critical environments and comply with NEP's regulation. Thank you.
That's awesome. Thank you for that contribution. Another question that we have here, what are the design features in FW architecture?
Okay, about this question, I will let out the software leader, Joseph, help to this answer.
Hello, everyone. And for the 5G server design, so based on the use case and telco segment, we would like to have the dual firmware, no matter BIOS or BMC, as a redundant, as a backup once the service is interrupted or in downtime, and the backup firmware could resume quickly and to lower down the overall downtime, and also can have the 5G service went back. And also on the other hand, and we will have the BMC supports the Redfish protocol, which is much more convenient, also safety in overall outband management, also for the PFR. And this is a great option as a hardware root of trust devices, and which is able to help users to prevent malicious firmware attack and to keep the server in safe status. And most important of all, and our server will comply with the a very important software vendor like Rail and Wind River, and to be certified by their program, and we can let our users to be easy to deploy ASUS server in their fields. So this is our design concept. Thank you.
Thank you. Very detailed explanation. We have a question for Oren now. Oren, what is Silicom key value proposing for the time sync cards?
Okay, good question. Of course, there are a few solutions in the market. So Silicom offer, first of all, software integration. Silicom offer all the drivers required for the time sync capability, initially integrating into the Intel Flexion, and after that into major vRAN vendors. We are also offering port density. We are offering 4 ports of 25, 8 ports of 10, 8 ports of 25, and 12 ports of 1025. It means we have a range of product that
Oren? Your voice was cut. Can you please repeat the end of your explanation?
Yes. So I was saying that Silicom have a range of port densities as part of our cards. So when a software vendor need to validate a card, we bring a range of products with identical software. It means we have 4 ports of 25, 8 ports of 10, 8 ports of 25, and 12 ports of 1025. Means that the software vendor have capability for every deployment model, whether it's rural area, urban, or dense urban deployments. All the same card, all the same technology, all the same drivers. So very simple to onboard. The last thing that differentiates Silicom is the accuracy. We provide today the highest accuracy in the market. We provide the longest holdover time. Most of the solutions in the market today provide between 4 and some of them also 8 hours. We are able to provide even 12 hours and 16 hours, depends on the card model. So just to summarize, we have the highest accuracy. We have software capabilities to support the integration into the vRAN application, and we have port density to meet every deployment model. And of course, as I said before, we're able to remove the switch between the DU and the radio units and provide all the capability through the card itself.
Perfect. Thank you, Oren. Another question here for you is, why do we need both Sync-E and PTP for time synchronization?
Okay, good question. I'm getting this one many times. So this question come up with two different capabilities. So first of all, the PTP or the 1588 is layer 2, layer 3. The drivers are running on the host while terminating all the time synchronization in the host itself. In order to improve the accuracy of the synchronization, we're implementing Sync-E. Sync-E is implemented on the layer 1. It means that it's in the physical layer between on the Ethernet connection between the RU and the DU, and we're able to provide higher accuracy that while we're using PTP assisted with the Sync-E. So both of these require for the accuracy that we're getting through these cards.
That's awesome. Thank you, Oren. I do have one more question for Albert. What features in ASUS 5G firmware architecture? What are the features?
Okay, sorry, I will let Joseph help to answer these questions on it.
Okay, so in our firmware design, then we will have the redundant. So we will do some fail-safe mechanism to keep the server status in safe and also quick resume. So this is the basic design. The second one will be the security enhancement. So no matter in BMC firmware or in the PFI, so with these two kind of solution, we would like to improve the overall out-band management security. So our key design, all in all, it will be the redundant and also security enhancement in our firmware management. Thank you.
Thank you. And we have time for one last question. This question here for Oren now. Oren, Silicom, ASIC, and FPGA cards offer similar functionalities. What is the value for end customers?
Okay, so again, if I'll go back to the slide, can I move back for the slide? Yes. When we're looking at the different add-in cards for 5G, we have a different functionalities. The EASIC provide a best cost-effective solution. The EASIC implement forward error correction for LDPC and turbo in LDPC in 5G and turbo in the 4G. Though this is a specific function that are offload from the host. This card is cost optimized, power optimized, and it provides the best value for this functionality. When we are looking at FPGA, this is open architecture. It's an open, it means that we're able to implement many more functionalities in the FPGA. We're implementing both the front hole connectivity and the acceleration capabilities. Of course, the power and the cost of an FPGA is much more than the EASIC. So each VRAM vendor need to decide themselves what they are looking to do. If they are looking for more software solution, EASIC, ACC 100 is the right solution. If they are looking to create more functionalities within the layer 1 or accelerate the layer 1, FPGA can provide a good solution. So it means that there is no definite answer, right or wrong over here. It's just decision which direction to go in order to implement the layer 1 acceleration. Both are good. Again, performance, price, power, and of course, functionality.
That's great. Thank you, Oren. Well, thanks to both of you, Albert and Oren, for the great presentation today. Thank live audience also for joining us today. Please do not forget to give our team a rating for the live recording. And this concludes our webcast. Thank you all so much.
Thank you.
Thank you.
Bye, everyone.
Thank you. Bye-bye, everyone.